The other law that we're going to look at is cosine law. Again, something that you studied in grade 11. So our goal today is I can use the cosine law to find angles and side lengths in non-right triangles. So again, what I've given you is I've given you a generic triangle, uppercase letters for angles, lowercase for our side lengths. And I have two different formulas here. And they're used in different ways. So the first one says a squared equals, and notice I have a, if I'm finding side A, means I'm also using angle A. So this is the formula that I would use if I'm finding a side length. Now the next one, cos A equals, okay, again, very important to notice that if I'm finding angle A, then I'm subtracting side A squared. If I don't have that, then I'm going to have a wrong answer. Now this is used if I'm going to find an angle. Now, actually, this second formula actually comes from the first formula. All it's been done is it's been rearranged into this form. So neither one of those formulas, or the sine law for that matter, are you responsible to memorize. Now, so when can I use them? So I can use this cosine law when I know one of the following. The first thing is the measure of three sides. Well, obviously, if I have all three sides, the only thing I could find is an angle. And that's why I would use cosine law. Okay, the other way I could do it is if I know two sides and what they call their contained angle. So it means if I know this side and this side, that I would also need to know the angle that holds them together. Now you've seen this before as Pac-Man going along and eating. So I always think of cosine law as everything dealing with my hands. So three sides with my fingers, or Pac-Man situation. So let's look at some examples. So the first one says determine the length of n in triangle MNP. So first of all, I see, can I use the cosine law? Yes, I can. You can see that we have this side length, and the angle that's contained between them. So the first thing we're going to do is notice we don't have A, B's, and C's, so we have N's, P's, and M's. So we're first of all going to rewrite our formula using those letters. I'm interested in N, so N squared equals. I also know that I'm going to have cos of angle N. So I often do that myself and I fill in the formula. So I have M squared plus P squared minus 2MP times the cos of N. So now I'm going to fill it in, and so that, again, isn't a really difficult part. So 13 squared plus 25 squared minus 2 times 13 times 25 times the cos of 105. Now this is the place now where students are going to goof up with the cosine law. It's here because they don't follow order of operations correctly. So what we're going to do is we're going to calculate everything that is separated by either adding or subtracting. So we're going to calculate that, which is 169. We're going to calculate 25 squared, which is 625. And then here we're going to calculate this whole thing here. Now, I'm going to punch into my calculator -2 times 13 times 25. And when I do that, all that together, I end up with a positive 168.2324. Now, you're saying, how did it turn positive? Well, remember when we talked about obtuse angles, we know that the ratio for cos of 105 is negative. So that number becomes a negative, and we have the -2, so that's why we end it with a positive 168. So now I'm going to add them all together to get 962.23 approximately. Take the square root of that, and we get approximately 31.0, and it is centimeters. Okay, so let's take a look at another question. Okay, the next question is determine the measure of angle C in triangle BCD. Again, I know three sides. I'm interested in angle C. Okay, and the reason I'm marking it on this is because I need to make sure that this number is the one that I'm subtracting in my formula. So, cos of c is b squared plus d squared minus our c squared, remember, all over 2bd. It's a matter of substituting our information in. So b, we have 650 squared plus 500 squared, and we're making sure that we're subtracting the 750 squared. Some really large numbers here. That's why we're using a calculator. And again, just substituting our numbers in. Now, what I suggest to do here, again, cosine law, if you're going to make a mistake, first mistake you'd make is you didn't subtract the right one. The second mistake is you're not following order of operations. Calculate the whole top first, the whole numerator, which in this case is 110,000, and then calculate the whole denominator, and then do your dividing, and you end up, let's see, I think one more zero. We end up with our lovely little decimal, or ratio, and then to find angle C, we find the cos inverse of that number, so we end up with approximately 80.3 degrees. Okay, so do a few extra steps in cosine law. Some people like cosine law, but if you don't follow order operations, you're not going to be successful. Now the next question is an air traffic controller at T, okay, so that's down here at T, is tracking two planes, U and V. Okay, so there's my two planes flying away. At the same altitude. Okay, so they're at the same altitude, so I don't have to worry that one's higher than the other, because if it was, that would change the whole situation as far as angles go. It says, how far apart are the planes? So in other words, they want us to find psi t. Now, what's different about this one is they have given us angles like this. So the green angle goes from N all the way down to this 15.3. So that's 75 degrees. And they also tell me 23 degrees is that blue angle. Now, I'm interested in the red angle because that's the angle in the triangle I'm interested in. Okay, so I'm actually really interested only in the triangle. So I'm interested in this angle here, and the way I'm going to calculate it is going to be, we'll call it angle T equals 75 degrees minus our 23. So we end up with it being 52 degrees. Okay, so sometimes it's useful then just to take all that information that's there out of the situation, and it's easier to see what's going on. So I know now that this is 52 degrees, this is 15.3, this was 10.7, and I'm interested in T. Notice it looks very different without planes in it and without a lot of extra information. So I can see it's the Pac-Man situation, so I'm going to write down my formula. T squared equals u squared plus v squared minus 2uv cos of, remember, angle T. Again, substituting our information in. And remember, what we're going to do with the cosine law is we are actually going to do a few extra steps so that we make sure that we're following order of operations and getting the correct answer each time. So when I do this, I end up with 234 and 114, and this time I do have a negative 201.5799. That makes sense because remember 52 degrees, the ratio of that's going to be positive. We know that from our obtuse lesson. Now when we add and subtract all of those together, we end up with 147.000. And finally, we know if we take the square root of that, we end up with 12.1 miles. And it's a word question, so therefore I'm going to put therefore the planes are 12.1 miles apart. Okay, so there's cosine law. And the only other lesson that's left is problem solving, which involves cosine law, sine law, as well as SOHCAHTOA. So all of those are part of our tools when we're talking about problem solving.